You've just finished frying. The food is perfect. It's crisp, it's golden, it's delicious. But now you're left with that pan of used cooking oil, and you're faced with that age-old question. Do you save it for next time, or do you just toss it out? On the surface, it seems like such a simple choice. But beneath that shimmering surface, a war has just been fought. An invisible chemical war between incredible heat, water, and the air itself, with your cooking oil as the battlefield. And the aftermath of this battle? Well, it has some very serious consequences for your health.
And we're going to break down all of that science today, right here on Everyday Simple Science with Ray. If you happen to be new here, we'd love it if you'd subscribe to the channel, and be sure to like and share this explainer. It really helps us reach new people who are curious about the what, why, and how of our universe.
So here's our plan. We're going to start with that invisible chemical war raging inside your pan. Then we'll learn how to spot the evidence, the signs of a fallen soldier. After that, we'll uncover the hidden health risks, learn the right way to reuse oil safely, and finally, we'll arrive at the definitive verdict.
All right, let's dive deep into the science. To truly get what's happening, we have to look at the oil on a molecular level. Well, before the stove is even turned on. You see, almost all cooking oil is made up of molecules called triglycerides. The best way to picture this is to think of a central piece, a glycerol backbone with 3 long chains of fatty acids attached to it. In its fresh, stable state, this is our hero molecule, but it's about to come under a multi-front attack. And that first attack begins the second your food hits the hot oil. The attacker? It's something you would probably never suspect. It's just plain old water. As the moisture in your food turns to steam, it violently collides with those triglyceride molecules. This process, called hydrolysis, breaks the bonds holding the fatty acid chains to their glycerol backbone, setting them loose. These newly free fatty acids are the very first wave of damage, and they immediately begin to lower the oil's smoke point. But water isn't the only enemy here. At the exact same time, the oil is under assault from the very air we're breathing. The second attack is called oxidation. At frying temperatures, oxygen molecules become incredibly reactive. They attack the fatty acids, starting a chain reaction that creates a whole mess of new, unstable compounds. And some of the most dangerous of these are called aldehydes. They are the real villains for both the oil's flavor and, more importantly, your health. So now, the oil has been broken apart by water and assaulted by oxygen. What happens next explains that thick, sticky, gummy feeling of old, used oil that I think we've all felt before. It's a process called polymerization. All of those broken, unstable molecules start linking up with each other, forming these long, tangled, heavy chains. These new, large polymer structures are what make the oil so thick and syrupy. The oil is quite literally tying itself up in knots. Now, the amazing thing is, this invisible chemical war, it leaves behind very visible clues. So how do we, in our own kitchens, see the damage? Well, it turns out it's easier than you might think. The battlefield is littered with evidence. So let's examine the evidence. Clue number 1 is the color. As you can see, fresh oil has that beautiful light golden hue. Degraded oil, on the other hand, becomes dark and brown. Clue number 2 is viscosity. That thick, syrupy feel is a dead giveaway that pulverization has occurred. And clue number 3, the smell. Those aldehydes we talked about create a rancid, acrid odor. But the final and most dangerous clue of all is that its smoke point has dropped, meaning the oil now burns at much lower everyday cooking temperatures. And that smoke, it isn't just a sign your pan is too hot. It's a flare, a distress signal. It is a very clear warning that the oil has crossed a dangerous line, transforming from a simple cooking medium into a source of toxic compounds. Consider this. A typical frying temperature is about 180 degrees Celsius. In a degraded oil, harmful, cancer-causing compounds like acrolein start to form at that normal temperature. You're not even burning the oil in the way we usually think of it. The oil itself is chemically broken, and it's now producing these dangerous substances just from being heated.
And you don't have to just take my word for it. The scientific research on this is absolutely clear. This quote explains that the aldehydes created during oxidation aren't some minor byproduct. They have real toxicological effects. They cause something called oxidative stress in the body, which is a key factor linked to a huge number of degenerative diseases. This diagram shows us that dangerous chain of events perfectly. It starts right there in your pan with those oxidized oils. Once you eat them, that leads directly to cell and tissue injury within your body. And where does that chain ultimately go? Well, it leads to some very serious long-term health problems. And the list of those problems is, frankly, quite sobering. We are talking about an increased risk for various forms of cancer, for heart disease, for neurodegenerative conditions like Alzheimer's and Parkinson's, even things like kidney dysfunction and diabetes. Suddenly, that simple kitchen choice feels a lot more important.
Okay, I know that was all pretty heavy, but it's not all doom and gloom, I promise. Because now that we understand the enemy, we can learn how to fight back. There are definitely ways to reuse oil safely, and it all starts with choosing the right kind of oil for the job in the first place.
The whole game is about chemical stability. You see, oils high in saturated and monounsaturated fats are much more resilient under high heat because of their strong molecular structure. On the other hand, polyunsaturated fats, like you find in sunflower or safflower oil, are much more fragile. They break down the fastest. So for high heat cooking, and especially if you're thinking about reusing it, you want to choose from the top of this list.
Now, once you finish cooking with a stable oil, these 3 steps are absolutely non-negotiable for safer use. First, let it cool down completely. Second, filter it meticulously. Any tiny bits of food left behind will act like little catalysts that speed up the decay. And finally, store it right. That means an airtight, dark container away from its greatest enemies: air, light, and heat. So after all of that chemistry and all of those warnings, what is the bottom line? Can you or can you not reuse that pan of cooking oil?
The answer is yes, but it's a yes with a big asterisk. You have to be smart about it. For those stable oils, if they've been perfectly filtered and stored, about 3 to 5 uses is a pretty reasonable guideline. But please know that is not a hard and fast tool. The most important tools you have are your own senses. If it looks dark, if it smells off, or if it feels thick and syrupy, its job is done. Get rid of it.
You know, your kitchen is really a laboratory, and every single meal is an experiment. It makes you wonder what other invisible science is unfolding right under our noses every single day. If you found this useful, make sure you subscribe to Everyday Simple Science with Ray. Like and share this video and turn on your notifications so you don't miss our next deep dive. And go ahead and click to watch the explainer that's on your screen right now. Thanks for watching.